all the information that's there on the assignment number 8 is everything you need to know to prepare you for the assessment. Now, here's something different. You actually get unlimited attempts for this. You get unlimited attempts for this assignment. So you can try as much as you can, keep practicing, 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 keep going over them over and over and over again, because all the information that's there is what it's what you're going to need in order to do well on the assessment. Okay. So assignment number 8 is right there, and the link is already posted. Thursday, we have office hours, 9 a.m. to 12 p.m. And on Thursdays, I also want you guys to review your Unit 4 digital notebook to study for your exam. So actually use your digital notebook to study for the exam, go over the notebooks, the slides. And on Friday, I would like for you guys to review all of your quizzes to prepare for the assessment. So review all your past quizzes and all the problems, because they're going to be very similar to the ones on your assessment. Okay, so here's a little schedule for this week that you can follow. So today, slide 75. On slide 75, we have our objective for today. Physicists will be able to properly study for their Unit 4 assessment by reviewing what is going to be on the test. I'm actually going to review with you guys what's going to be on the test. Okay. And we're going to go into slide 76. Slide 76 is our Black History Month highlight. Okay. We have Granville T. Woods. He was a successful inventor. And when I say inventor, I mean like real inventor. He had over 150 patents. A quarter of them were in electromagnetism and electricity. Now, patents, that word just means that when he invented something, he trademarked it, so no one else will steal that it was his invention. No one else will claim that it was their invention. So he trademarked a lot of his inventions. The most notable invention is the telegraphony, which think of it as an early form of Twitter. It's a machine that allowed trains and train stations, so train and train stations, to send messages to each other, which at the time was not possible. And this device enabled communication via both voice and telegraph, which was unheard of at the time in the mid to late 1800s. Fun fact, he won 2 lawsuit cases over Thomas Edison. Edison claimed he invented this first, but he failed to provide proof. Now, Edison was known to do that. He was known to steal inventions and claim it as his own, and just file a lot of patents. Yes, indeed. Yes, indeed. Thomas Edison was a very greedy person. He patented a lot of inventions and he claimed it as his own. And he did that to a lot of like lower income and people of color, POC people, inventors, which was super horrible. But the really great thing is that Granville T. Woods actually had proof that this was his invention. He had documents to support it. So those 2 lawsuit cases, he actually won, and he was rightfully able to claim that that invention was actually his. And yep, and the fights he had with Tesla too. Did he actually ever invent something? He did invent stuff. He modified the light bulb. That's one of the things he did. He modified the way people communicate through communication known as a telephone now. But all those other ones that are claimed to be there, he just had patents for them. So that means if someone uses them, he will get money for it and he will get credit for it. So he wasn't not just he was an outright inventor, but he had really powerful lawyers, very, very powerful lawyers. And he was very good at just investing money in patents. So he kept patenting everything. He kept patenting everything. So when it got invented, he actually had, quote unquote, the rights for it, the rights to actually own it, which they're horrible. That's what happened with the first TV, the first ever film ever made, the first ever film ever made on TV. He actually won the lawsuit over that. And so, yeah, he's a very controversial person, but these are the facts that hopefully people know now. His lecture was deadly, though. Oh, it probably was. Indeed. And this is the information for him today. So Granville T. Woods won, and he won the invention. He's a very great person to highlight today. Awesome. Now we're moving to slide 77. Okay. Slide 77. Hopefully that piece of knowledge gave you a little bit of of curiosity. I know Anke Gabriel seems very curious about Thomas Edison. So keep looking at them and see the true history behind him. Now, for today's Do Now, I want you guys to read the slide and answer the two questions in the bottom. It's basically going to give you information on our Unit 4 assessment, and then we're going to go over it together. Okay? So it's been 5 minutes going over, working on slide 77. There you go. So this now slide 77 is just giving you an overview of the Unit 4 assessment. The main thing I want you guys to remember is that this week's assignment, the review, the quizzes review, is going to mark a total of 100 points since we started this quarter, the third quarter. So after this assignment, you will officially have 100 points in your 100 total points in your grade book. Now, if you haven't actually achieved those 100 points, that will determine what your grade is. So, for example, out of the 8 assignments, let's say you add up your point and you get maybe 77. Since we have 100 points at this point, 77 over 100 is a 77. So that means you will currently have a 77 in my class, not including the extra credit that you may have done. Okay, so that means next week's assignment is worth 40 points. So the assessment is worth 40 points. So it means it's officially worth 40% of your overall grade. So make sure you study and prepare for it. Okay, here's the breakdown of the Unit 4 assessment. It is 25 questions. And the 25 questions are broken down into these 3 different setups. They will either be a combination of multiple choice, check all that apply, and fill in the blank. So exactly the same way I've been doing the quizzes, that's how the 25 questions will also be laid out. It'll be a combination of those different formats. And each question is worth 1 point for a total of 25 points right there. The second portion is a short answer question. It's the same layout, it's the same format as the assignment you did a couple of weeks ago, the write it, record it, draw it, talk about it in another way. It's the same layout for that one, and that's one question is worth 15 points. Okay, it will be worth 15 points. So 25 plus 15 equals 40 points in total. Now, these are the topics that you will be tested on. Okay, these are the 6 topics I will be testing you on this assessment, from the law of conservation of energy all the way to using the law formulas to solve for problems, the ones we have been going over these past 3 weeks. We're just going over the do now at this time, Fernando. Okay, welcome back. And the blue part is the slides. So for you to study for this exam, I put out the slides where they're located. So if you go to those specific slides, you can actually go to those slides and it will go to the specific topic that you're trying to study. Okay, and so that's what the blue words and numbers are. Now the purple one is the number of questions. So the number of questions is how many questions going to be in the assessments. For example, the law of conservation of energy will only have 2 questions in the test, and then the law formulas that we have been going over these past 3 weeks, there's only going to be 3 problems for those ones. And the biggest chunk are these 4 middle ones. Each of them is worth about 20%. Each of them is about 20% of the test. So 5 questions each. And talk about energy fields and Coulomb's law and the law of universal gravitation. So you might want to focus on these middle 4 topics. Okay. How many points is a Unit 4 assessment worth? We already put that. They are worth 40 points or 40% of your overall grade. Okay, so that's the answer to that question right there. It seems like the most ones that people have been putting has been the energy fields and comparing and contrasting both law formulas, which is good because these are the two of the main ones that we'll be focusing on this test. Awesome. Thank you, Fernando, for your response as well. Yes, the law formulas as well. I see there's a couple of you guys of the law formulas as well. And that's good because we have been going over these for the past 3 weeks. Okay. Awesome. Thank you. Now, Now we know the layout of the exam. So I'm going to give you an example of one question to be on there. Oh, not yet. Sorry, my bad. Before we do that, let me review this for you guys first before we go into that. So let's go to slide 78 and go and let's follow along with about 7 minutes. And I'm going to go over all the topics we have gone over for Unit 4. Awesome. Thank you. And now there are six different colors of pen in the little slide. That is for each topic we have gone over. Okay. So let's start off on the top left. Let's start off with the brown color pen. It's the law of conservation of energy. This is the only part I want you to know about the law of conservation of energy. This is the only information I want you to know, is that energy cannot be destroyed, only transferred. Okay, that's one of the main things to remember on the law of conservation of energy. You can't create, you can't destroy energy, you can only transfer it from beginning to end. And the units for them, units for energy, are joules. That's how you measure energy, in the form of joules. Okay, there you go. Right there. And that's it. That's the main part I want you to know about that first topic that we learned over, the law of conservation of energy. Okay. Now we're going to go into the black pen color on the right side where it says energy fields. There's 3 of them. In that big white box, I want you to type the 3 of them, the 3 energy fields, which are gravitational, magnetic, and electric. Okay, gravitational, magnetic, and electric. I'm gonna make this a little bit big for you guys. There we go. And then below, there's another bullet point. I want you to put the word all. All are affected by force. So that means gravitational, magnetic, and electric fields are affected by force. Force is the main contributor that affects these 3 energy fields, force. And obviously, we're going to find this out when we go over our formulas, because the formulas is finding the force of these energy fields. Okay. Now, before we go into the law formulas, let's go to the left side in the middle. There is some words in blue comparing and contrasting energy fields. Now, I separate into 2 sections, gravitational on the left side and both magnetic and electric on the right side. Now, these are the main characteristics I want you to know about these fields. So let's start off with gravitational fields. On the left side, they are only attractive. That means they only pull towards each other. They pull towards each other because of gravity. They are macroscopic, which means they deal with big objects like Earth, space, the moon, stars, everything up out there. And then on the third bullet point, it says deal with mass. Deals with mass. These are the ones that deals with mass in kilograms. So that's the main characteristic that differentiates gravitational fields. And the last one is that it's associated with the law of universal gravitation. The law of universal gravitation and gravitational fields are very closely related to one another. They use each other to figure each other out. Now, on the right side is the characteristics of magnetic and electric fields because they're so similar to one another. So right below it, we have they are both, put the word both. Magnetic and electric fields are both attractive and repulsive. That means they pull towards each other and they push away. Pull and push away, attractive and repulsive. They are also microscopic. They deal with very, very, very small objects such as protons, electrons, atoms, waves, all that good stuff. And they deal with, there's another white box right there, they deal with charges. They both deal with charges, whether it's positive or negative charges or even a neutral charge, they deal with charges. And since they deal with charges, we are talking about Coulomb's law. They are associated with Coulomb's law because they do deal with charges. Okay, so these are the characteristics that identify both of these 3 fields into one another, respectively. Now we're going to move on to the orange words, which is Coulomb's law versus law of universal gravitation on the right side. They have the same units. And at this point, I'm pretty sure you guys know what that is. The same units are newtons. It says newtons is how you measure force. The only way to measure force is in the form of newtons. Okay. So they have same units because both formulas find out force, the strength of force of these energy fields. The second part I put is that they have similar formulas. Right below it, there is purple words. This is the next topic, comparing and contrasting Coulomb's law versus the law of universal gravitation. As you can see, the formula looks pretty similar to one another. They only differentiate in two major aspects. On the left side, we have Coulomb's law, and on the right side, we have the law of universal gravitation. So let's start on the left side, on Coulomb's law. These are the characteristics that are unique to Coulomb's law. They are very strong. They have very, very strong forces. They are both attractive and repulsive. They pull in and they push away. And on that empty spot, I want you to put charges. They deal with charges in. Q1 and Q2. Q1 and Q2 tells you the charges of the Coulomb's law. And right below, we have Coulomb constant, which is a lowercase k. So the Coulomb constant and the charges are unique only to Coulomb's law. And on the right side, we have the law of universal gravitation. These are the characteristics that are unique to the law of universal gravitation. For example, they are very weak forces, very, very weak forces. They are only attractive. They only pull towards one another. And on the empty space, I want you to put mass. Masses. They deal with masses. Okay? They deal with masses. M1 and M2. And they have a gravitational constant as a capital G for the variable. So M1, M2, and the G are only unique to the law of universal gravitation. Okay? And last but not least, on the bottom left, we have the pink words. This is using law formulas to solve problems. This is what we have been going over these past 3 weeks. I just wrote down the steps. Step 1, read the problem and highlight keywords. Step 2, identify if it's Coulomb's law or universal law of gravitation. Step 3, write down the correct formula. Step 4, plug in the values to the formula. And the final step, step 5, find the final answer. Okay? Here. So all these 6 topics are what we went over these past quarter 3. Now, I don't want you to use the slide just to study for this. I want you to also use your notebook and your quiz assignments to study for it because I want you to practice problems, problems. So don't just focus on this one side to study. I want you guys to go beyond it. But this is a really good starting point so you can figure out the main parts of each of these topics. Now, let's go slide 79. Slide 79 is our guided practice. This is an example of a question that's going to be on the assessment. Now, I know we haven't dealt with a lot of graphs, but this is a pretty simple graph. So hopefully it should still help you out in answering the questions, okay? So don't let it trip you out too much. You guys know most of these things from your past knowledge, okay? So I would like for you to read the little small passage and analyze the graph and use the graph to answer question number 1, which is fill in the blank. Question number 2, which is multiple choice. And question number 3, which is a CER statement. So you answer the question in a claim, evidence, and reasoning statement, okay? So we're gonna spend 7 minutes working on that. If you have any questions, please let me know. But that's what we're gonna focus on. So use the graph to answer question 1, 2, and 3.